In this video we look at a pretty quick example from section 3.6, or the idea behind section 3.6, which was how to take the derivative of inverse functions. Okay. And in class we showed several examples about how to do this. In this video I want to kind of walk you through the steps in general for how to take the derivative of a function g of x, which this function g of x is, which is the inverse function of some function f of x. Okay, and just a real quick note on notation. Okay, the derivative of some inverse function of the inverse function of f of x. Okay. The notation here is that means that have some function f of x that's given, okay, and g of x is its inverse of f of x, which means that when you compose f composed with g of x, that you will get x because g of x is the inverse of f of x. That's what it means to be an inverse. There's a common notation used for the inverse. Rather than inventing a new notation, say g for the inverse, the notation for the inverse function is the function f with a little -1 on it. Okay, this is the notation for the inverse function of f of x. Okay, and you should be careful here that f with that little -1 does not mean 1 over f of x. Those are not the same thing. This is a tricky notation for the inverse function. Okay, so the question is, how do you take the derivative of the inverse of a function? Okay, if you know what the function f of x was, whose inverse you're trying to find the derivative of. Okay, so you start with the steps. Step 1 is to write down the inverse notation. F composed with f inverse of x is equal to x by definition of inverses. Step 2, take the derivative of both sides. Take the derivative of both sides, okay, which means that via the chain rule on the left-hand side, you're going to get the derivative of the outside function evaluated at the inside function, and then you're going to multiply by the derivative of the inside function. And the derivative of the inside function is just the derivative of this inverse that we would like to try to figure out how to find. The derivative of the other side, x, is equal to 1. And therefore, step 3, when you solve for the derivative of the inverse function, you can solve via that for algebra. So the derivative of the inverse function is equal to 1 over the derivative of the outer function evaluated at the inverse function itself. There is the formula in general. This is a general formula for any inverse function's derivative. Sorry, I meant to write general formula. Okay, so how does this get used? Example. Okay, let's say that the function f of x is equal to the tangent function. Tangent, let's say you know that. Okay. Okay, and we want to find the derivative of the inverse function. The inverse function is called the arctangent function, arctangent of x. Okay, and our job is to find the derivative of the arctangent function. Okay. Well, according to this general formula, okay, what we need to do is to do 1 over the derivative of the outer function. The derivative of the outer function is the function that we knew about, tangent. So that will be secant squared. That's the derivative of the outer function. And then we need to evaluate at the inverse function itself, which is at the arctangent of x. Okay. So our job now to figure out this formula is we need to simplify a little bit. Simplify with trigonometry. Okay, and that's what I want to do on the next slide. We've done one example of this in class, but I'd like to do another one now. Okay. So if we're going to add a page below, we need to complete the derivative with respect to x of the arctangent is equal to 1 over secant squared of the arctangent of x. Okay, now here's where we need to recall, okay, a little bit of trig, that the arctangent of x, arctangent of some number x, is going to be equal to some angle. Arctangent of x is equal to theta is the same thing as saying the tangent of some angle is equal to x. These say the same thing. These are synonyms, let's say. Synonyms. Okay. Which means that the tangent is equal to x divided by 1. Tangent is the same thing as opposite over adjacent. So if you draw a triangle of some angle theta, then the tangent is the opposite over the adjacent. Opposite side of the angle theta over the adjacent side of the angle theta, which by Pythagorean's theorem tells you that you will get the square root of 1 plus x squared. Okay, you'll get square root of 1 plus x squared for the hypotenuse from Pythagorean's theorem. Okay. And now, to finish the secant squared of the arctangent, okay, we just need to find the secant squared. Arctangent of x was equal to theta. So let's read the secant squared. Okay, let's read secant squared off of this graph here. Can you find the secant of the angle theta? Secant is 1 over the cosine. Okay. So the secant, I need to look at 1 over the cosine. 1 over the cosine is equal to, let's go over here, cosine of theta is the adjacent over the hypotenuse. So you'll get 1 over the square root of 1 plus x squared. Okay, so if you look at 1 over the cosine of that angle, you will get the square root of 1 plus x squared, which is the same thing as the secant. If you square the secant, you get the square root, you get the secant is square root of 1 plus x squared, so when you square it, you get 1 plus x squared. Okay. Which then tells us that the derivative of the arctangent of x is equal to 1 over the secant squared. The secant squared is 1 plus x squared. And there is the derivative from the general formula for the inverse function's derivative and doing a little bit of trigonometry. So ends this video.